Lesson 68, Intro to Trig Ratios. Trigonometric ratios. Okay, first of all, we are going to define trigonometry. Trig. Okay, so basically, this is just the study of the relationship between sides and angles of triangles. So today we're just going to focus on 3 of those ratios in right triangles. So the first one is called the sine, and we shorthand it as SIN. The sine of an angle, we'll just call it A, is equal to the opposite leg. So in a right triangle, you have 2 legs and a hypotenuse. So it's the length of the opposite leg divided by the length of the hypotenuse. The cosine, and shorthand we use COS. So the cosine of an angle is equal to the length of the adjacent leg over the length of the hypotenuse. So I'm not writing in the word length every time, but when you see adjacent over hypotenuse, that just means the length of those segments. And then the last one today, tangent. We shorthand it TAN. And that is equal to the opposite leg over the hypotenuse. It is actually equal to sine over cos. Sine over cosine. And when you divide fractions, you keep it, change it, flip it, and the hypotenuses will cancel, and you'll get the length of the opposite over adjacent. Why did I put hypotenuse?
What's the opposite?
Did I say adjacent and wrote hypotenuse? That's super weird.
What's the opposite?
The opposite leg is, if you're looking at the angle, so the angles that we're taking sine, cosine, and tangent of are acute angles. So it will be a leg that is opposite that acute angle. So if you put your pencil on the point of the acute angle and then just do straight through the middle of the triangle, the leg you come to is the opposite.
Pretty much the one side of the angle isn't touching.
Yes. Exactly. The leg that it's not touching.
Oh, yeah.
Wait, I guess it would touch the hypotenuse though, wouldn't it?
Yeah.
So yeah, it's the side it's not touching. Okay, so we're going to draw a picture here of a right triangle. The sides we call little a, little b, and little h for hypotenuse. The angles, the acute angles across from the little a, we'll call that angle big A, and the other acute angle big capital B. So if I wanted to find the sine of angle A, I would do the length of the opposite side, so it's straight through, or the side it's not touching, so A, little a, over little h. And then the cosine of A would be,
Wait, can I try some?
it's adjacent over hypotenuse.
Adjacent leg and over
A remembers the opposite. The adjacent leg is the other leg. There's only 2 legs in the right triangle. So the adjacent leg is the other leg that you didn't use in sine.
B.
B.
Oh, right.
There you go. And then tangent is opposite over adjacent. It's just the 2 numerators of your cos, sine and cos. A over B. So if we wanted to find the sine of the acute angle B, we look at angle B and we need to do opposite over hypotenuse, so it's little b over h. And cosine of B would be little a over h, because it's adjacent, and tangent of angle B would be b divided by a. So we have a little saying called SOHCAHTOA. SOHCAHTOA. So you're looking at the sine is the opposite over the hypotenuse. So we're just looking at the first letters of the trig function and then the fraction that comes after it. So SOHCAHTOA. I've seen it written like this, so ka toa.
That way's better.
And that way you can remember, oh, the sine is opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. So I've seen it written like that too, which you can do.
I like that way.
Either way,
Both ways.
this is a little more visual, so you can remember that it's the second two numbers are fractions. Okay, we're going to do an example with a right triangle that we know is a Pythagorean triple. So 3, 4, 5. This is A, B, C. So if I wanted to find the sine of angle B.
Ooh, can I try?
Yes, please.
SOHCAHTOA. Oh, that's a B. 3, 5.
3 to 5. Excellent.
This is
And the cosine of angle B, so adjacent over hypotenuse, so I look at angle B, so it's 4 over 5. And then the tangent of angle B
3,
is 3/4. Good. It's just the numerators of the sine and cosine. Yes.
Okay, so would they ever ask us to find the sine, cosine, and tangent of like the right angle?
No. I'm trying to think. The right angle,
How would there be
90
an opposite
degrees,
angle? 'Cause
the cosine is 0.
It's
At
an
90
opposite
degrees,
angle.
the
Oh,
cosine
so you're
0
still
and the
recording.
tangent is 1. That's okay because we're not done.
Oh, yeah.
Yeah.
I thought we were missing track this.
And if the sine is 1, yeah, you can see why the sine would be 1 because the opposite is the hypotenuse, so it would
Yeah.
be 1. But then the cosine is 0. Anyway, yes, Harrison.
So we don't have to use like the sine and cosine on calculators.
Yes, we do. I'm going to teach that to you this very minute.
Hey, what if we already know how to do that?
It doesn't matter. I can still teach you. Yes, Samuel.
Can you zoom
Wait, will we ever have to find like the exact number?
Huh?
I would like calculating.
It depends on what your definition of exact is. Okay. We have to find A and X here.
I can do
So this is what you look at. You look at what angle's given, 50 degrees, and you know the opposite side. Okay? So we're going to use, with the opposite, our trig functions are sine and tangent. So we're going to need to use sine to find one and tangent to find the other. Okay? So sine of 50 degrees equals the opposite, which is 6, over the hypotenuse, which is A. So you cross multiply, and you get A sine 50 equals 6. Then you divide 6 by the sine of 50 degrees. And whenever you use the calculator, you have to make sure it's in degrees so you can get the correct answer. So you go to your mode,
I need my calculator.
and it has to be on degrees. So you do 6 divided by cosine, no, sine 50 degrees. Just type it in, and
I'm gonna try.
sine has these sine, cos, tan right down here. And you push enter, and it's 7.83244. We'll just round the nearest tenth. 7.8.
So that's what I was asking, like, do you have to write it as like that?
Yeah, yes.
Wait, how do you change it to degrees so that I have to be negative 22? Is that gonna show me?
Oh, so go to the mode,
Okay.
and then you go down 3, where it says radian to the right, and then push enter.
So, will it ever ask us like to write it in terms, like, sometimes in some problems it asks us to write it in terms of pi. Will it ever ask us to just write it in terms of the cosine and the sine?
No, I won't, because you're finding lengths, and so you have to know what the length is, and putting it this way doesn't help. So no. Yes,
So how did
Rebecca?
you cross multiply to get the A
That's right.
equals 6
If-
over 6?
that's a good question. If you imagine sine 50 degrees over 1, then you have a proportion, and you can cross multiply like this, and it's 6 times 1.
Oh. Oh,
Okay. Okay, and then we want to find x, so we're going to have to use the tangent of 50 degrees, and that's opposite over adjacent, so it's 6 divided by x. And by the same process, you can find x by doing 6 divided by tangent 50.
Wait, let me do it. Don't tell me the answer.
Round to the nearest tenth, so excellent. I guess if you're rounding to the tenth, you want that 0.0, just like you said. Okay, that's the end of the lesson.